Hello friends, welcome back again. In this video, I will explain you how we can communicate LS VFD IS7 model with Delta PLC 14SS2 via RS-485 communication in RTU mode. So let's get started. First of all, I will show you my hardware which I am using for this video. This is my LS VFD IS7 model, and this PLC we are using, this is 14SS2, and these two wires already in previous videos I explained about this hardware. These two wires we connected with this VFD. So I will open also my hardware and I will show you. You will be understand. This cover I will be open, and here as per scene you can see this is our RS-485 communication terminals. This is the white color is S minus and this is S plus. So we just close this cover and this is also we will be connect. So first of all, I will tell you about the parameters in VFD, which parameters we have to be set. I will make it little near and after you will be understand. First of all, you have to be select this mode one, and after you have to be scroll down, and after you can see this first this six number parameter command source. Just go to an program, and after you can see this is all have a settings in 0. Keep it. First one is FX and RX means, and second one also, and we have to be choose this one INT 485, and after click on the program, after this store will be stored your value. And next you have to be set the frequency reference. Frequency reference also we need for RS-485. It's already I selected, but if you like to understand, enter this program, and after you can find this all parameters 4, 5, 6, 7, which is encoded. Many of the settings you can find, but we have to be select INT 485. So click enter. After this will be select, and after next I think so no need to be select any parameter. So just right click, go to the communication section. When you find this one communication section, here you can see this is the communication section. This first you have to be set the address of your VFD. So I address put it here one. Click at the enter button, and here you can see this is 2, 3, which ID number you like to be set, you have to be set. I select first this one because I have just only one VFD, and after next you have to be set the protocol. You can see this one protocol, which is you have to be click enter, after which protocol you like to be set, and this is you have to be select. So I select this Modbus RTU, so select enter, and after go to the next parameter, you have to be set the bond rate of your VFD. Now this is 9600, any other also you can choose, but I choose this one 9600 and click enter. And after next you have to be set the parity. Click on the program, and after you can see I choose this one data bit 8-bit data and parity even and stop bit 1. This is sim enter and click finish at the scan mode. After you will be go back. So our VFD parameters are now set it complete. So now this same parameters we have to be set in our PLC also. Okay, so let's go to the software. First I open this one, Delta PLC software, and here already I designed this program. In previous video also I explained about with the Delta PLC with the Delta VFD. So same program will be run by the LS VFD. So no need to any data changes. Little I will explain you just. This is the M1002. You can understand maybe. This is for the single pulse generator special memory relay. And this one move command we are using for the communication protocol of the PLC. This is the H87 and D1120. This the special address we have to be set, which is we set in the VFD. Already you know I just explained 9000 bond rate. Better for better understanding, I open the manual of the PLC, and after I show you, you can just go to the for communication, go to the 320 page, and after you will be get the communication page. And here as per scene you can see this is the communication protocol setting. You know, for COM to RS-485 setting you have to be set this parameters. Parity bit, which is we are using in the VFD, we are using E1, so we have to be use this one 1 right? And this data bit, first bit, this data length we have to be set. This is if you put 0, this will be 7 data bit selects, and if you put 1, this will be 8 bit data. So we are using this is RTU mode, so we have to be select this one number. First bit 1 number we have to be used. So we will collect our this binary, and after we will be multiply in the hexa value. So first you have to be use 1. In second bit you have to be use this one double 1. So 1 this one and 1 double 1, and next you have to be chosen B3 stop bits. Which stop bit we are using in the VFD? 0, because of we stop bit, sorry, we use stop bit 1, so we have to be choose 0. So this is 1 1 1 0, and next we have to be choose same this one 4 bits B4 5 6 and 7. We will use this one in the VFD. This is the 9600, right? And after this one, this is value how much comes. If we will go to the page, I show you once text notebook, sorry, I think so. Yeah, notepad. If we will go to the notepad, after I will show you how is our binary 1 1, sorry 1. This is first we used 1, second we used 1, and third we used 0, and this is after 30 and after 1, but it's I write the wrong value. We have to be write the right from the left. So this is you have to be write it here same. Wait, I will show you again. 1 to 0 0 0 1 1 1. This is your binary. How this is binary? You can see this is first bit 0, we choose 1, so this is the 1. So in second bit we used 1 1, even parity we have to be choose this 2 bits 1 1, so we use this 2 ones. And in third bit we used this top bit 1, so stop bit 0, because using stop bit 1 value we have to be set the 0, so this is the first 0. And in third bond rate we setting for this one 9600, so we used 3 zeros and 1, so this 3 zeros and last 1, and this value we can convert in the, and this binary value we will convert into the hexa. So we can open also our calculator. So in calculator you can see, I will just directly type it in the hexa 87. After you will be understand, can see this is the hexa 87 and binary value is how much, 111000001. So this H87, I hope so you will be complete understand about the hexa value. This H87 how becomes. So we have to be set the special value, this H87 our protocol of the PLC to the VFD, and this is the special data register D1120 for COM2 communication. Okay, and next this we have to be for this COM2 RS-485 ASCII and RTU mode selection. This we have to be make the set. If we use for ASCII, we make this one reset. If we like to be use this RTU mode, we have to make this one set condition. And next this one M1161, this is also the selection of 8-bit and 16-bit data selection. And this is M1123, this is also same in for receiving data for the communication of the PLC to VFD. And this is next M1127, this is also mode read reset, mode read write instructions. And this is M1129, this is receiving timeout. If you can read in the manual, also I will show you in the page hexa. Same this one. Yeah, here also we can see this one. You can see the program in the PLC and comments are shown below. Look like he later made and example gives us. If you like to be complete understand, I refers to you must be read this manual of the Delta PLC. After you will be complete understand. This is first you see M1002. You will make the first internal memory and move H87 D112. What's the meaning of communication protocol 9608E1? This is setting already he is complete explained in the manual. And next he says set means M1120 retaining the communication protocol. And next he put also move K100 D1129. What meaning? Communication timeout 100 milliseconds. And next K2 D0 for the COM2 selection. And same this next datas he explained, but no need this other datas. We have to be just understand about these three datas, four datas. Same also have many other settings he explained in the manual. You can read this one all, after you will be better understand. So next what we do, we choose this one M1011 for what? This is 10 milliseconds clock pulse. This will be continuously giving the clock pulse because this is a special relay of the PLC. And this is M112, this is the sending request close contact we used because of when this is giving the pulsing, this will be must be in close. If this is on, it will be stop the. And after we make the increment of at D0, and also we make the falling edge for the M1122. So continuously it will be giving the pulses at D0, and after this D0 we compared in the next program with the M0, M1, M2. You can choose any other also, no problem, no issue, but I am choosing this M0 and M1 and M2. When D0 equals with 1, after M0 on D0 when equal with 2, this value when increment coming at here, and after this value will be completed, we designed it here 4 values. When 4 values completed, after it will be automatically reset. So same as this one we decided here, yani when D0 equal or greater than 4 value, it will be moves 1 in the D0 data register. That's the we're using for increment. And next, here we make the communication and read write the values into the VFD. M0, this is first select we will M0, and this is using the move write command K1 H6 H4 D1 K1. This is H4 is our data register for this from the VFD, and this is our first drive address. Device address is K1, and this is H6 is total value, and this is H4 we are using for the write the frequency. That's I will show you in the, I have some pages for the VFD. Where go, this is the pages. This no need, this already I explained. So this is also we can find in the pictures already I have. Yeah, here now I open this one page and you can see this one. This is in the manual of the VFD. This decided this is read write data for the command frequency. This is the hexa address they write for the 5. But what we have to be do, this is the procedure. We have to be from the 05 we have to be -1 value, and we have to be set the 4. So as same this address 05, we set it here 0 H4 hexa 4, and D1, that's any data you can choose. This is nothing issue, D1 D2 D3 D4 whatever, and this is the one value we have to be send it to the H4. And same as this is on the sending request to the VFD, because we are writing the data at the D1, this will be moves this value in the H4. This is the special command of the PLC. Also this we can find in our mode read and mode write command. If you, I think so, here MOD RW, when we type, after you can find it this value here. COM3 COM2, yeah, here you can see this is the for COM2 RS-485 move write instruction D1256 D up to D1295. This data registers can be store the send data. Instruction sends out data. The data will be stored in the this data registers. User can check the send data in these registers. So all data you can find in the manual. This will be complete explanation is available. How you can set the communication. This is here you can see this the basic instructions, and here you can see communication instructions. MOD RD means read Modbus data. 101 mode write Modbus data. Forward operation for VFD. Reverse operation for VFD. This is the communication instructions. This already he shows. For example, this mode read or mode write, when you data command used, this will be special function. And after have many instructions here you can find for other functions also, floating point, many of the. So this is for the our frequency writing data H4. And next also we designed here a one program for this the operation our VFD to run forward, reverse or stop mode, same like. And this is the we are using for command control command, means any frequency this D2, how we use this one? See, M10 when on, after this value K2, 2 value moves into the D2. So this is the D2. And if we M11 on, after this 4 values move into the D2. And after when M12 we will make it on, this K1 value, 1 value moves into the D2. This D2, this is for the command operation we are using. This command operation for what? This is I show you in the manual. Also you can see this is the in next page. Next page I will show you. I will make it a little zoom, and after you can see. Here you can see read write data for the B0 stop bit, stop the VFD, and bit 1 we have to be put forward operation. This B2 reverse operation he says. So when we have to be stop the VFD, we have to put the 1 value. Here in the first bit we have to be make it on for the stop function. So and we have to be like to be forward run, we have to be put the here 2 values, because of in the binary when you understand complete binary, this is the start from 0 up to B6. This is same as I show you. This is 6 values. H5 we have to be write in the D2. If we write 1 value, this is for our stop mode the VFD. And if we write the 4 value in D2, that's the forward command. Forward or reverse. Sorry, we have to be recheck this one. Yeah, this is you can see. If we put the 2, this will be in the forward operation performed. And if we put the 4, this will be reverse operation performed. Because of in one put of the first bit, 1 stop, and if in the second bit we have to be the put the 2 value, and in the B2 third bit we have to be put the value 4, because of the in binary first bit is 2, second bit is 4, third bit is 8, fourth bit is 16. Look like if you like to complete understand, you have to be learn the binary, after you will be understand. So this is when we put this one 2, it will be forward, and this will be 4, this will be reverse, and when K1 value we will put, it will be stop. And same as next we use this for reading the value of the from the VFD. Same as H6, H3, when we reading the data at the H9, it's the starting from the frequency, output current and output frequency and output voltage look like yani this, and K3 this is the total value how much we like to be read. This D20 address also you can use other, no problem. This is we using here, and this is DTM command is also is very special command for to reading the data. I will show you in the manual, you can write it here DTM when you write, after you can find it here the description of DTM. DTM instruction. Binary octal decimal. So that's now I forget, I think so where this go this all addresses and all details you can find in the PLC manual. So this is the special command of the for the reading datas, and here your coming is the current of your VFD, and here is coming your amperes of the VFD, and here is feedback comes from the bus voltage of the VFD. So we will be first check this one all. I will download this program into the PLC and let's check and make the monitoring mode, and after we will see. You can see this is our M1143 is now set, and this is now is communication. Yeah, now our communication is okay because of this is working properly. So after one more thing you can be understand, when your bus voltages are coming feedback from the VFD, so think about your communication is okay. Now you can see this is our bus voltage is coming, and here our current, and here our VFD output will be, frequency will be shown. So we will be just on our, I will make it small this one, and we will open our VFD, and I will make it the small, and also our motor is connected with our VFD. That's really better, you can see this. So see, where is our data? This one, yeah, this is our H4 is our for the frequency setting. Here is now nothing have any frequency, we have to be set in the D1, we have to be set some value. So in the present value we will be set, for example, K1234 means 12.34 Hertz. I typed and click enter, and after you can see our 12.34 Hertz are now ready. And if you like to change this value, for example 11.11 Hertz we need, so this will be go to the 11 Hertz. So after we have to be give the command for clockwise or anti-clockwise. So I will on my first M10, when we will make it M10 on, our VFD will be starts in the forward condition, because of this is the 2 value. When we moved into the D2, after it will be runs the forward 2 value. First we can see in the manual also. Yeah, here you can see read and write the data for the stop 1, and in the forward condition we have to be put the 2, and in the reverse operation we have to be put the 4. So now our VFD is running the forward condition because of 2 value is the moved into our D2, which is the, this is command section. So I will stop this one, and I will on this, I will move this value K4, and you can see VFD is stopped and go into the reverse condition, and see now it's in the reverse condition. So when we like to stop the VFD, so we will move this one, move one value into the D2, make it on, and you can see our VFD is now going to stop mode. Right now it's in the stop mode. So again one more time we will be checked with the VFD. Now it's, I will put again set on for the forward direction, and now we will change the frequency. For example K2000 I will type, means 20 Hertz. Now you can see drive is going now at the 20 Hertz. Now motor is our going to 20 Hertz. And if you like to be go into the clockwise, you can on the M11. Now it's first stop with the acceleration, and after go back to the 20 Hertz. Now it will be start again. You can see it's now starting again. And when reach at the 20, after it will be done. And also feedback, if we like to be see, you can see here is a which value frequency we set at 20. This is now 2000. 2000 means this is 20 frequency, and this is 132. This is the voltages of our VFD. Here is 132 you can see, and this is 132 our VFD voltage, and this is the K559. This is the bus voltage, and when we will go into the VFD this parameters, after we can see the bus voltages, right? So hope guys, this I will put 1050 for example, and click enter, and after you can see here is our frequency also change at the 10.50 Hertz, 10.50 Hertz, and 73 is our output voltages are shown here. This is the output voltage and this is the bus voltage. So hope guys you will be understand about this program. If not understand anything, you can send me the message in comment section. I will give you feedback as soon as possible. So thanks for watching. Allah Hafiz.